In this short video, you're going to see how to find the length of a piece of a curve, arc length. So let's suppose that a curve is described by a function y is equal to f of x on an interval from a to b. Then the length of the arc, or the length of that piece of the curve, is given by, traditionally we use the letter s, the integral from a to b of the square root of 1 plus dy dx squared, take the derivative and then square it, dx. So let's see a pretty simple example. Suppose we want to study the graph of y is equal to sine x. Think for a minute. Do you know what that graph looks like? I think you do. Here is a quick sketch of y is equal to sine x, one little piece of it. And it goes up to 1, it goes down to -1. One full wave goes between 0 and 2 pi, and this point right here is pi. Sorry, let me clean that up. This point right here is pi. So suppose we want to find the length of just this one little piece of arc, this one piece of the graph from 0 to pi. So let's just apply our formula that we had before. We have to find the derivative, dy dx. The derivative of sine x is, that's right, cos x. So the arc length is going to be the integral from 0 to pi of the square root of 1 plus cos squared x dx. And what you will see most of the time, these integrals will require the use of a calculator or a computer. So you probably won't be able to easily find an antiderivative of this, but if you type this into your calculator using the integral feature of your calculator, go ahead, I'll give you a minute to do that, and be careful with the parentheses when you're squaring the cosine of x. Are you ready? Okay, put that into your calculator, the integral from 0 to pi of the square root of 1 plus cosine of x squared dx, and you should get 3.820. Great job. The end.